Hello and welcome to C and Data Structures training. In this session, we are going to learn about pointers in C. So, in this session, we will be covering about a little bit about the memory structures of computer. We will be learning about how we are doing the addressing in C, addressing in sense of a physical address in the computer. We'll be doing a basic introduction to the pointers, like what are pointers and how pointers are used. We'll be doing some pointer manipulation, like we'll be doing pointer arithmetic and doing some problems related to pointers, and we'll be summarizing the concepts of pointers. So let's see how we store our data in the memory. So computer stores data in memory slots. Each slot has a unique address, and variables store their values in these memory slots. This table shows you how we use the memory slots, how variables are stored in the memory. Uh, Basically, if you see, we have declared two variables here. One is I, and one is we have declared array, and we are referring to the second element of array. So I is equal to 40. So here I is declared. I is declared as 40, and this is the address of I. So this is just a representation of address. This might not be the actual value of the address, but just to make you understand, we are assuming address to be 1000. The address could be different in different systems, so this is not exactly address, but just a reference to it. I mean, just a hypothetical representation of an address. So variable I having value is stored in address 1000. Similarly, a of 2 equal to z. So a of 2 having value z is stored in the address 1006. So this is how we store variables in computer memory. So pointers in C are nothing but they are referring to the address, those memory slots. So whatever memory slots we have here, this one, pointers are used to denote or point to the memory slots or these addresses. Pointer stores the address of any entity. So if you want to store the address of I, suppose I have declared a variable I equal to 40, and I want to know the where I is stored. I can declare a pointer for it, and pointer will help me out in giving me the address of I. So again, just to revisit, pointer stores the address of any other entity. Okay, it refers to a memory location. So here again, this example, I equal to 40, and the address of I is 1000. So if we say any pointer which is pointing to I, it will be nothing but it will be storing the address of I, which is 1000. So pointer stores the address of another entity. That means pointer, in this case pointer is storing a value of I, and it refers to a memory location. So whichever memory our variable is stored, pointer points to that memory location. Just consider this very small example. Int I equal to 5, we have declared one variable 5. Now this is how we declare the pointer variable with a star over it. So this is an integer type of a pointer. So this declares a pointer variable. Star is used to declare a pointer variable, and the type of pointer is integer pointer. Pointer ptr equal to ampersand I. Now this ampersand represents the address of I. Okay, so if we want to get the address of any entity, we just have to give it like this, and of I, ampersand points to the address of I. If you say printf star ptr, like pointer equal to percentage d star ptr. So this how we interpret star and we will see later part of this session, but just to as of now, for our understanding, uh, and represents the address of operator and star represents the value of operator. So if suppose I am having star PTR, like here I am using star PTR, that means I want address, I want value of PTR. If I am saying and PTR, I am saying it as address of PTR or address of I, whatever it is. So why do we need pointers? Simply because it's there? No. Pointer has some meaning into it, and it is used in many circumstances in C, and it's very helpful. If you have remembered this example, or if any example that we have done in all the previous sessions, we have used scanf a lot, and the syntax of scanf was like something like this: scanf %d %I. So basically what does it do is scanf gets the value from user and store it into the value of the variable whatever we have given. So here in this case, if I give I equal to 5, so the 5 will be stored at the address of I. That's how we that's how we add n% at the while we using scanf function. So what actually is a pointer? A pointer is a variable storing an address. It's very simple. Pointer is a variable storing an address. Pointer is not storing the actual value. So pointer just store the address of a variable. It won't store the value of that. Let's see this example once again. Int I equal to 5. I'm declaring I as 5. Now I'm declaring a pointer, integer type of pointer, integer star ptr. Now I'm assigning a value to the pointer equal to address of I. Okay, how I am reading this ampersand I is pointer equal to address of I. Okay, so here pointer equal to address of I. Printf I equal to %di, printf star ptr equal to now how I interpret this? I interpret as value at address of I, value at address of ptr. So value at address of ptr is whatever stored in I. So value at address of I is 5. So it will print 5. Okay. Similarly, ptr equal to %p, and we'll say ptr. If we do like this, it will give whatever is stored here, which is the address of I. Okay. So it will give us the address or the location, physical location of variable I where we have stored it. So this is the output. So this address could be different in different machines. It is just a representation of an address, but every time when if I run a program, I can get a different value. So it is all dependent upon on our system in which we are running. So let's revisit what is ampersand and what is star. So here those ampersand and star are called as a twin operator in pointer. So ampersand is nothing but address of operator. So how I am interpreting ampersand? Ampersand gives me address of anything which is right to ampersand. So here ptr equal to address of j. So what ptr will be storing? ptr will be storing address of j. Here say ptr is storing address of j. Address of j is 1001. So ptr is storing 1001. Okay. Similarly, star represents dereference operator or value of operator. So if I say value at address of ptr, I will be getting 99. So suppose ptr equal to 1001, if I'm saying star PTR, that means value at address PTR, value at address 1001 is 99, so I'll be getting a 99. So pointers are also helpful in passing the value by reference. What is pass by reference? So let's consider these two examples. First we will see this example. So we have this function which returns void, function f which accepts j and assign and reassign the value. Okay, now we have another function g where I have assigned one value 3. Okay, if I call f of I, okay, what will be the output? I mean, or what will be the value of I if I call this f of I? Okay, so here let's walk through the code again. Int I equal to 3, I am calling f of I, so in f I am passing 3. So j will become again j will be assigned to 5, but nothing will be done here. So if I use I after this thing, I'll be getting I as a 3, not as 5, because whatever is changed here will not be reflected here. So this is an example of pass by value. We are not passing any reference or anything over here, so anything changed here will not be reflected here. This example shows pass by reference. So we have declared one function f which accepts an integer pointer, and what we are doing is we are changing the value at address ptr equal to 5. Okay, so when we are calling a function g, I am declaring int I equal to 3 and calling f and giving the address of I. Since I am using pointer ptr, I have to give an address something. If I just plain give I, if I just give I, it will not compile, or it will throw me some error at while I am running the code. So wherever I am wherever I am having a pointer as a parameter of a function, I have to pass some address. So here I am passing address of I. So what it is doing is it is changing at address of I equal to 5. So whatever operation we do after that on I will always be taken as value 5, because here we are changing value at address of I. Here we are just doing some assignment operator into some other variable, so this will not change the value of I. Here the value of I will be changed. So this is how we use pass by value. This is how we use pass by reference. So pass by reference is also called as modifying behavior in argument passing. So whenever we are writing any code which changes the behavior of the argument, we have to be very careful, because the further execution of the code will be very much dependent on our code. In this case, if whatever assignment we have done and all, it is locally to this function. So if anything wrong went into this function, this will not affect anything outside the scope of this function. But anything went wrong in this function will affect outside the scope of this function, because we are changing the value of I here, and that value will be used further, so the behavior of the program may change. So we have to be very careful while using pass by reference, and we should be very thorough what we want to do in pass by reference. So here I will be 3, here I will be changed to 5. So one more illustration we'll do. Let's say we have two variables, I equal to 5, j. So now what we are doing is we are declaring an integer pointer. So declare an integer pointer variable ptr. ptr is an integer pointer. Okay, now we are having a double pointer, like pointer to pointer. Declare a pointer to pointer to integer. Now here I am assigning ptr equal to address of I. So ptr will be assigned as address of I here. Pointer to ptr, pptr equal to address of ptr. Since it is a double pointer, so it will accepts the address of a single pointer. So ptr is a double pointer, it will accept the address of a single pointer. So what is stored in ptr is a address of a single pointer, which is ptr. Now we are changing value at address ptr equal to 3. So whatever is value at address ptr is 3. So the value of I will also be changed to 3, because whatever ptr is storing is address of I. So value at address of I will be changed to 3. Value at address pptr, so it will change. First it will get me what is the value of pptr, which is value of a single pointer, which is address of I. So how I'll execute this code? First I am getting address of ptr, and then I am changing the address value at address of ptr equal to 7. So now I will become 7. Again ptr equal to ampersand j, like ptr equal to address of j. So now ptr will point to 10. Now if I say value at address star pptr equal to 9, that means same operation, value at address ptr, that is address of j, will be assigned to say 10. Okay, so now star ptr equal to end of I, that means value at address pptr equal to address of I. So if we say here value at address pptr equal to address of I, so address of I is nothing but address of this, which is stored here. Now if I say star ptr equal to -2, okay, it will change the value of I as -2. So why the value is changed to -2? Because value of address ptr here, what ptr is storing, ptr is storing value of so ptr is having address of I, so value at address of I is equal to -2. So I ultimately I'll be changing the value of I. So this is how pointers are used to change the or do the reassignment or change the value by referencing to the address of a variable. So let's touch upon pointer arithmetic. So what is pointer plus 1? Pointer plus 1 is a next memory location. Next memory location in terms of it will not point to any random memory location, but suppose if I have an integer pointer, and if I say pointer plus 1, it will allocate me it will allocate me that much bytes that an integer takes. Okay, so whenever we do an increment of a pointer, it always increments the size of a data type. So suppose my memory location is say 1001, and if I am saying pointer plus 1, it will not give me 1002. It will give me it will add 1001 with the size of an integer. Okay, so maybe suppose size of an integer is say 4 bytes, so it will give me 1001 plus 4 bytes. Similarly with ptr minus 1, it will decrement the memory location address with the type of pointer we are referring to. Pointer into 2 and pointer by 2, these operations are not valid. If we perform these operations, this will give us error. So just be sure that we should not use these operations in pointers. So again, let's revisit some example. Let's suppose we have declared two variable, float a4, float array of 4 as a float, a floating pointer. So here ptr equal to a pointer. We have not initialized it, so it has some, it does not have any value. So now ptr equal to address of a2. Okay, so ptr is pointing to address of a2. Value at address ptr equal to 3.14, so it will change a2 to 3.14. I am doing ptr plus plus, so what it will do, it will increment my pointer to next float, which is a3. Value at ptr equal to 9.0, so again a3 will be equal to 9.0. ptr equal to ptr minus 3, so I am decrementing my pointer with 3, so it will point to a of 0. Again I am changing a of 0 to 6. I am adding ptr equal to plus equal to 2, so ptr will point to a of 2. I am reassigning it to 7, so it will point to 7. So this is how all the operations are there. Here we are doing a plus plus operations. Here we are doing a simple mathematical ptr equal to ptr minus 3. Here we are doing a plus equal to. So all the combination of plus minus operations are possible. Only thing is that multiplication and division in pointers are not possible. So pointer arithmetic in array, how we do pointer arithmetics when we talk about array. So let's suppose we have a float array of size 4. Okay, we have a pointer and pointer is pointing to address of a2. Okay, so type of variable is floating pointer. A2 is equal to, so this is how we reference an element in an array when we talk in terms of pointer. So a2 is equal to a plus 2, value at address a plus 2. So any array, suppose I have declared an array as a of 4. So if I say what is a is nothing but a is termed as a pointer to the starting location of an array. So a of 0 is nothing but star of a. So a is nothing, a is the starting point of a address at which our array starts. Okay, so since address at which array starts is a and I am adding 2 to it, so it will increment my pointer with the 2, and value at that address will give me some value which is equal to a of 2. So this is how the behavior works. ptr equal to and of a address of a of 2, or ptr equal to address of value at a of 2, or ptr equal to a plus 2. All these are equal. A is a memory address constant, so a points to the memory at which our array starts. ptr is a pointer variable, so if I assign ptr equal to a, that will be a valid operation. Only important point to get from this slide is a is the memory location at which our array starts, so that this makes a meaning a of 2 is equal to value of address a plus 2. So let's do some precautions while using the pointers. So what are the pros and cons of pointers? Pointers will give us more efficient code. So if we are having something with memory constraints, or when we are talking about our program efficiency, if we use pointers, it will give us more efficient program and more convenient program with respect to our performance and efficiency. Cons are pointers are difficult to understand and difficult to manage, so it is mostly error prone, so it requires some amount of effort to get expertise in pointer. So once you have expertise in pointers, then it's okay, we can get rid of this con. But initially if you start with pointers, also it is difficult to debug because uh, we are dealing with address spaces and all. So address space is not that humanly readable format. So if we just keep on printing some address and all those stuff, we don't recognize what is happening in the program. And if something went wrong in the program, it will be difficult to debug and correct our errors. So be sure that we are very comfortable with program before using the sorry we very comfortable with pointers before using those. Okay, so just to summarize our points, pointer stores the address of another entity. So another entity means a variable or an array, or it's generally the variable. Address of operator is AND. So if we are using AND, we will be getting the address of that entity. Star is a dereference operator or a value of operator. So when we use star, we will get the value of that particular address. Pointer and array, we have touched upon pointer and array. So how pointers are linked with arrays? If we have declared an array, say int a5, so a is nothing but the pointer to a location from which our array starts. And we have touched upon pointer arithmetic. So what is pointer arithmetic? What all operations are possible in pointers? For example, addition is possible in pointers, subtraction is possible in pointer, but multiplication and division is not possible in pointers. So let's do some coding practice. Let's write some code. First problem is write a function to swipe two numbers. So let's use pointers to do that. This is the program which is swiping two numbers. What I am doing is I have declared one function, swipe function, which accepts two pointers, two integer pointers p1 and p2. Now what I am doing is in this swipe function I am declaring one temp variable, storing the value at address p1 in the temp variable. Now I am changing value at address p1 equal to value of address p2 and value of address p2 equal to temp. So what we are doing is in this operation we are interchanging the values which is stored in p1 and p2. So we are changing the values which is stored in address p1 and address p2. So when this function is finished, the changed value will be reflected in the main function. So what we are doing here in main function, we are having two variables a and b and inputting it from the user, calling a swipe function and printing it. So in the swipe function I am passing address of a, address of b, because we are accept we wants pointer here. So let's run the code. So let's compile the code. So code is compiled successfully. Let's run the code. Enter the value of a, let me give us 4. Enter the value of b, let me give us 5. So value of a is 5 and b is 4. So after we call swipe function, the value of a and b are changed. So this is how we use pointers when we talk about uh, doing some operations in changing the value. Also this is an example of pass by reference, because we are passing the address of a and b, and whatever is done in this function is reflected in the main function also. So this is how we do it. Let's take one more example. Write a C function to sort an array of 10 elements of 10 integers values in ascending order. Here we need to we will be given an array of 10 integers, and we have to sort the uh, array. How we will do it? We can use a very simple brute force technique called bubble sort. Bubble sort will what it will do, it will run two loops. First it will run loop on element 0, and it will check all the elements from element 1 to element 10 or element 9, whether if element 0 is the least value. If whatever so from in the second loop which we are running from 1 to 9, whatever is the least value, it will be assigned to element 0. Then we'll go to element 1, and the second loop will run from element 2 to 9. We'll find the least value from 2 to 9, and it will be assigned to element 1. Then we'll be running a loop from, then we'll be pointing our variable to 3 and so on, and we will be ending up sorting an array. So let's write a code for it. So this is how we write the code for sorting the array. So what I am doing is I am using a swipe function in a little different way, just to show that how it can be used in other way also, where I am expecting a pointer variable, an integer I and integer j, x and y. Swipe function is like this. Uh, uh, these are the parameters. So temp equal to value at address p plus x, px equal to py, value at address py equal to temp. So this performs swiping. So in this I have used all flavors of using pointer and array combination, where this px is equivalent to star p plus x, and I am using all these flavors in swipe function. So let's see what we are doing in main function. So in main function what I am doing is I am declaring a variable, an array I and j I am declaring. Now I am taking input from user. Okay, in this section what I'm doing, I'm running two loops. One loop runs from 0 to 10, second loop runs from I plus 1. That means whatever is the value at of I, it will start from position, uh, say suppose I equal to 0, this j will start from position 1 and so on, and till the end of the array, and say check if a of I is greater than a of j. If a of I is greater than a of j, then it will swipe the value. That means the swipe function will come into picture, where a of I will be swiped with a of j. So let's run the code. Okay, let's compile it. Compilation is successful. Let's run the code, give some values. So array after sorting is 23, 23, 434, 43, like this, and 133. This is the last element of the array. So this is how we print the output. So this gives us very illustrative way of how we can use pointers with array, and how we can use pointer arithmetics and all. So I hope you enjoy this session. This will give you more understanding on how to use pointers in C.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section. And don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.